Hello everyone, welcome to Engineering Archives. In this video, we are going to look at learning problem number 5 for this chapter, dot products. So this problem says, determine the magnitude of the components of the force F, which is equal to 56 newtons, acting, acting along and perpendicular to the line AO. So just like the previous question, they want us to find the two components for the force F equals to 56 newtons, and one of these components should be parallel to this axis AO. One component should be along this line AO, and the other component should be perpendicular to this line AO. Okay, so let me redraw this right angle triangle to make it more understandable. This is the parallel component, and this is the perpendicular component. The force F, parallel component, and the perpendicular component. And let me put the two lines on each of these, and these lines denote that we are talking about the magnitude and not the vector itself. Okay, so we know which formula we have to use, and that formula is the magnitude of a component is equal to the force vector dot producted with the unit vector along that axis. So we need the vector for the force and the unit vector parallel to the axis. So let's first find the force vector. In order to find the force vector, we will first need to find the length vector. And that length vector is length vector from point A to point D will be equal to 1.5i minus 3j plus 1k. And from this we can find the unit vector along the axis AD by dividing this by its magnitude. And so the answer that we end up with 3 by 7i minus 6 by 7j plus 2 by 7k. Alright, and finally we can get the force vector F by just multiplying this unit vector by the magnitude of the force. So our force vector is multiply 56 with this unit vector along the line of the force, which is AD, and we have 24i minus 48j plus 16k. Now that we have our force vector, we can start finding the unit vector along the axis of the line AO. But before we do that, I would like to bring to your attention one very important point. And that point is that when you are finding the unit vector or any vector to use in these formulas that we have learned for this chapter, you should notice that whatever two vectors we are dealing with, both these vectors need to intersect. Or in other words, the tails of these vectors, they need to intersect their tails, okay? So since our force vector F is directed in this direction from A to D, our unit vector along the axis line also needs to start from A and go the other direction. In other words, their tails need to meet. Okay, so you can't find the unit vector from O to A. It needs to be from A to O, just like the force vector is from A to D. Both of their tails need to meet, okay? So we can find the unit vector from A to D by first finding the length vector from A to D, and that is equal to 1.5i minus 3j minus k. Okay, now we can find the unit vector from A to D by dividing by its magnitude, and we end up with 3 by 7i minus 6 by 7j minus 2 by 7k. Now that we have all vectors that we need, we will simply take their dot product to get the magnitude of component parallel to the axis. Okay, taking the dot product, and the answer that we get is 46.86, which we can round off to 46.9 newtons. Now that we have magnitude for the parallel component, we can find the perpendicular component to the axis line using the Pythagoras theorem. And once we apply the Pythagoras theorem, I'm going to skip to the last step. We get the magnitude of perpendicular component is equal to 30.7 newtons. So this question was almost similar to the last question,